Okay, so when we talk about the coordination of the cardiac cycle, we just need to be aware that the heart is said to be myogenic, which means it's a muscle which is self-stimulating. So it's able to generate its own electrical activity, and it all starts in this region here called the sinoatrial node, which is found in the top corner of the right atrium. And when this generates electrical activity, this wave of excitation spreads across both atria, and it only goes across the atria. It doesn't spread down to the ventricles, which is good now because it means only the top half of the heart is being excited. And when that wave of excitation moves along the membranes of the actual cardiac muscle cells, it's going to cause them all to contract. So if we link this back to the cardiac cycle, this initial wave of excitation taking place in the both atria is going to cause atrial systole. So the atria are going to contract. So that's going to cause all the blood that was in the atria to be pushed down into the ventricles. And then what will happen next is all this electrical activity, the wave excitation, will all end up at this region here called the atrioventricular node. And when that activity arrives here, it will move down the septum, but not yet. It's going to be delayed by about 1/10 of a second. And that's really important because what it's going to allow is for the atria to do their full contraction without the ventricles pushing against them yet. And that's going to mean that the most amount of blood can still be squeezed into the ventricles. So about 1/10 of a second. And then that wave of excitation is going to shoot down this middle region here called the septum, just like the septum that's found between your nostrils, same sort of thing. And within that septum, there is a special tissue called Purkinje tissue. And that Purkinje tissue, what it's doing is, if you look at this green area here, this is representing the Purkinje tissue. You can see electrical activity isn't able to get out to the top of the ventricles yet. The electrical activity is forced all the way to the bottom or the apex of the heart, which means contractions will only then start from the bottom first. So there's another image here. So there's our SA nodes. Electrical activity is spread across the atria, arrives at the AV nodes, and then the electrical impulse shoots down the septum through the Purkinje tissue, and the electrical activity makes its way to the very bottom first. So this is really useful. This makes for really efficient contractions of the ventricles. So it's analogous to if you're quite conscientious about how to get toothpaste out of a toothpaste tube, you might decide that you should really squeeze from the bottom of the tube first. That makes sense. You're not going to leave half the toothpaste down the bottom. So it's a similar thing. You're going to get a contraction happening from the bottom, and the contraction is going to make its way all the way up to the very top of the ventricles. That's going to make for really, really efficient emptying of the ventricles. So let's link this back to the actual cardiac cycle. So when there's no activity from the SA nodes, we would call that diastole. It's fully relaxed. SA node is self-stimulating, so it creates a wave of excitation. That's going to cause atrial systole. We then get a slight delay at the AV nodes, and that's going to allow the atria to fully contract and empty the blood out of their chambers into the ventricles. Electrical activity is going to fire down the septum through the Purkinje tissue to the very bottom of the heart without any activity escaping the top parts of the ventricles. and this is going to allow for a contraction that starts from the bottom of the heart and squeezes up and up and up and up and up, and that will create very, very efficient emptying.